For my project, I've chosen to do facial recognition and how it relates to linear algebra. I chose facial recognition because prior to my degree in actuarial sciences, I had originally wanted to obtain a degree in biology in order to work in forensics, and a large part of forensics is facial recognition. What is facial recognition? It is a mathematical software program designed to analyze, categorize, and then record data provided in each image. Each image recognition is generally set to find similar patterns between thousands, if not millions, of other images to identify someone based off of their facial characteristics. How exactly does facial recognition work? Facial recognition works in a series of complex steps. To start off, an image must first be produced, such as a passport or a driver's license. From there, the prominent facial features such as eyes, mouth, chin, even ears are determined and marked for each image. Ideally, each face is captured in the same lighting and pose to increase accuracy. After pinpointing the main features, the image is changed to a grayscale, and then excess background noise is eliminated. The newly altered image is then placed into a template and compared to numerous other images in search of a matching pattern. If the image is not found, then it will be recorded into a database in hope of eventual identification. This is a visual representation of the process of facial recognition. Step 1 includes the original image unaltered. Then step 2 includes the pinpointing of dominant facial features such as the red dots above indicating eyes, and then the image is turned into a grayscale, and finally additional information that's not necessary is cropped out. Then we move to step 3, which is where the remaining information is transformed into a certain database and processed in step 4 to look for similarities in the images and different patterns to be able to successfully identify the image based off of facial recognition. What can facial recognition be used for? In career fields, numerous industries have begun research into facial recognition since its development. Law enforcement, medical sciences, forensics, social media, sporting events, school systems, and even security bureaus have all used facial recognition to benefit their companies. It could also be used to improve society. Facial recognition has made a remarkable evolution in such a short amount of time. Nowadays, with the use of real-time analysis, it has helped with the safety and protection of public or private information. For example, retail. In recent years, facial recognition has helped lower the violent crime incidents associated with retail stores by 91%. It is also helpful with diseases. Scientists have been able to compute an algorithm to aid their facial recognition searches in finding facial characteristics consistent with those of certain diseases. A rare disease called DiGeorge syndrome has used facial recognition to successfully identify those with the disease in 96% of cases. Now on to the main purpose of this presentation. How exactly does this relate to linear algebra? In order for those searches conducting the facial recognition to do so in a timely manner, it is a result of an algorithm specifically designed to lower the dimensions present in the image, drastically minimizing the search results. It also leads to the ability of using dimensional subspace. Eigenvectors and eigenface. During the facial recognition process, the data is scanned and recorded as a series of numbers into vectors and matrices, allowing for patterns to be detected. The idea is based around the use of PCA, potential component analysis, in order to do the actual strong pattern detections. Essentially, it breaks down the human face into a list of ingredients, allowing for each category to be properly sorted and measured. Below is a representation of a matrix, which in this case would be each person's unique facial pattern, and the vector would represent each of the facial ingredients. Eigenvector and eigenface continued. The development of eigenfaces came from L. Surovich and M. Kirby in 1987. Later, the idea is expanded up by M. Turk and A. Pentland as a method of facial classification. The idea essentially led to the ability for computers to calculate the eigenvector of a covariance matrix. This process supplies the computer with the algorithms to conduct the processing of that value by eigen decomposition on multiple images in a timely manner. There is also a representation of eigenface examples on the right side of the page. In conclusion, throughout the years, advances in computer science have taken drastic leaps in discovery and research. One of those being the hugely beneficial software made to process images and allow for mass recognition to become so popular and effective. Scientists are still working to perfect the system and eliminate any problems they have encountered, such as difficult facial angles, mood expressions, and partial images. Without the use of linear algebra alongside many other mathematical processing components, this much-needed solution wouldn't be possible, which is astonishing seeing how prominent math can be in our society. On the following page are all of my sources.